This video illustrates demand and supply. Consider a competitive market for used copies of Greg Mankew's textbook, Principles of Economics. Suppose the daily demand for the books is given by the equation willingness to pay, or WTP for short, is equal to 150 minus Q, while the daily supply of the books is given by the equation willingness to accept, or WTA for short, is equal to 10 plus Q. Let's start the analysis with the demand side. We know that the willingness to pay, or WTP, shows how much a person values a good and is measured by the maximum amount that person would pay to acquire a unit of the good. So basically, the willingness to pay is the price. Illustrating the willingness to pay equation in terms of price, we insert P in place of WTP. Therefore, we have P is equal to 150 minus Q. To find the highest price anyone will pay for a book, we have to think about this in terms of the first buyer. So the first buyer demands Q is equal to 1, and substituting this Q is equal to 1 in the willingness to pay equation, we have 150 minus 1 as being equal to the price, and that gives us $149, and this is the highest price anyone would pay for a book. We can also illustrate this demand information in a graph. On the vertical axis, we have price. On the horizontal axis, we have quantity. Using the willingness to pay equation that we simplified in terms of P, we can think of it in terms of if Q is equal to 0, what would P be? So P would be 150, illustrated on the vertical axis. If P is equal to 0, then Q would be 150, which can be put on the horizontal axis. Connecting those 2 points gives us the willingness to pay curve, which is simply the demand curve. Now, moving on to the supply side of our problem. We know that the willingness to accept, or WTA, is simply the reservation price of a potential seller who will be willing to sell a unit only for a price at least this high. Therefore, WTA is simply equal to price. Using this information, we can rewrite the willingness to accept equation as P is equal to 10 plus Q. And using this seller's willingness to accept equation, we are now able to draw the supply curve and add it on to the graph that we found earlier. How do we do that? So we start with P is equal to 10 plus Q and ask ourselves, if the output is equal to 0, what would be the price? So basically the price would be equal to $10. So inserting the $10 on the vertical axis or the price axis, we have 10 there. And then it's at that point that the supply curve starts from. So you draw the supply curve in that manner, and that's simply your supply curve. But then the question is, how do we know that the demand curve is downward sloping while the supply curve is upward sloping? We pick that from the equations that we were given. So recall the willingness to pay, or the demand curve, was equal to 150 minus Q. So we know that the demand curve will be downward sloping or negatively sloped because of the minus sign in the equation. And similarly for the supply curve, we know that the supply curve will be upward sloping or positively sloped because of the positive sign in the equation. Next, what is the lowest price that anyone will accept for their book? And by anyone in this particular case, we are talking about sellers. The lowest price can be found by asking the first seller how would they sell their first unit. So Q is equal to 1, inserting it back into the equation gives us a price of $11, and that's the lowest price that the seller or any seller will be willing to accept for their book. So from the analysis that we've done so far, naturally the question that arises is, how do we find the equilibrium price and quantity? But before we even get into the weeds of how to find those two values, it's clear from the graph that the equilibrium happens at the point at which the supply curve and the demand curve intersect. So point A is the equilibrium in the graph. So then how do we find the equilibrium price and quantity? Recall the two equations that we had in the beginning. So we had willingness to pay and willingness to accept, where the QD signifies that we're looking at the demand side, and the QS there shows that we're looking at the supply side. Equating those two equations, we can simply see that we get 150 minus QD is equal to 10 plus QS. However, it doesn't really matter whether we have QD or QS, because in equilibrium, QD, or the quantity demanded, is equal to the quantity supplied, which we can simply call Q. So inserting Q into the equation that we had, so we have 150 minus Q is equal to 10 plus Q. Solving for Q requires us to just take like terms to the same side, and what we end up having is 2Q is equal to 140, and solving for Q there gives us a quantity, equilibrium quantity of 70 units, and that is shown on the graph. How do we find the equilibrium price? So equilibrium price can be found by inserting the equilibrium quantity that we found of 70 into either the willingness to pay or the willingness to accept equation. In this particular case, we can just start with the willingness to pay equation, which is 150 minus Q, and inserting the 70 there, we get an equilibrium price of $80, and that is shown on the graph. However, it is good practice to also just try the equilibrium quantity of 70 units into the other equation, which is the willingness to accept equation. And if you get the same value, then you know that you're doing the right thing. However, if you get a different value, just know that you've made a mistake somewhere. Now, suppose the price of used textbooks was $100 instead of the equilibrium price of $80 that we found earlier. How does competition lead buyers and sellers to converge on the equilibrium price and quantity if the initial price is higher than the equilibrium price? So what this information tells us is that suppose the price rises above the equilibrium price of $80, let's say it goes above to $100, what we're going to see is we're going to have excess supply, and we call that excess supply because the quantity supplied, which is QS, will be greater than the quantity demanded, which is QD. And of course, the implication is that there will be more textbooks that will be supplied than those that will be demanded. And of course, many sellers will not be able to sell their books at a price of $100. So competition is going to result into a situation where sellers begin to underbid one another until the price converges to the equilibrium price of $80. And looking at a similar problem but in a different light, how does competition lead buyers and sellers to converge on the equilibrium price and quantity if the initial price is lower than the equilibrium price? So what we're simply assuming is that, say, price falls below the equilibrium price of $80. So let's say it falls to P double prime. We can call it P double prime, but we're talking about a price, any price lower than $80. What we're going to observe is that there will be excess demand, and we call that excess demand because what we see is that the QD, which is the quantity demanded, is greater than the quantity supplied, which is the QS. And the implication is that if the prices were to fall below $80, the process would simply work in reverse to what we observed on the previous slide. At a price of, say, $60, there would be excess demand, and buyers would outbid one another to snag a textbook until the price converges to the equilibrium price of $80. So the next question is the competitive equilibrium a Nash equilibrium? And the answer to that question is yes. So the question was simply asking us is the point A that we found as a competitive equilibrium a Nash equilibrium? And the answer is yes. And the reasons for why that is a Nash equilibrium is because both players in this particular case, the buyers and the sellers, will be acting in their best self-interest to arrive to point A. And once they arrive at point A, they will not have any incentive to change their behavior. Everyone who is buying or selling a book at the market price will be earning some sort of surplus, with an exception, of course, with buyers and sellers in the 70th exchange. Basically, there won't be any incentive for people to forego these rents or surpluses in equilibrium. Here we discuss the two concepts of consumer surplus and producer surplus. The consumer surplus is represented by the blue triangle ABC on the graph, and it's defined as the consumer's willingness to pay for a good minus the price at which the consumer bought the good, and that is summed across all units sold. On the other hand, the producer surplus is represented by the triangle ABD on the graph, and it's defined as the price at which a firm sells a good minus the minimum price at which that firm would be willing to sell the good, and that is also summed across all units sold. In, in terms of how the consumer surplus or the producer surplus are calculated, since the consumer surplus or the producer surplus are represented by triangles, we calculate either consumer surplus or producer surplus by using the formula for the area of a triangle, which is half base times height. And so in the case of the consumer surplus, that calculation is 70, which is the base multiplied by the height, which is 150 minus 80, and that is divided by 2, and that gives us a value of $2,450 as consumer surplus. Similarly, for the producer surplus, the base is 70, and that base is multiplied by the height, which is 80 minus 10, and that is divided by 2, and that gives us a value of $2,450 also. However, you must take note that the two values are just equal by chance, and that is because the demand curve is exactly as steep as the supply curve. Or in other words, the absolute values of the slopes are equal to 1. Is the competitive equilibrium Pareto efficient? Yes, the competitive equilibrium is efficient. And the reason for this is because the surplus is as large as it possibly can be. So it is impossible to redistribute the surplus in any way that makes someone better off without making any other person worse off. So we have a situation where we have some sort of zero-sum game. The next question is whether the competitive equilibrium is fair. So the issue of fairness is hard to determine, and this is because in this particular case there are 80 potential buyers who are not willing to purchase a book at the equilibrium market price of $80. Whether this outcome is fair is probably depends on why they don't want to buy a book. Could it be that there's a free online version, or because the book won't be that useful to them, or is it because they are broke? So it is hard to determine the issue of fairness. You could also similarly think about whether sellers are being treated fairly. Amending the problem that we had from the beginning just a little, suppose that at the beginning of a new semester, the demand for used copies of the textbook increases to WTP is equal to 175 minus 0.5 multiplied by Q. What would be the price and the quantity at the new equilibrium? So the calculations that would follow from here would just be similarly to what we've done before. So we use the new willingness to pay function, which is 175 minus half multiplied by Q, and that can be expressed in terms of price because we know that the willingness to pay is the same as the price. So we have price is equal to 175 minus half multiplied by QD, where the subscript D just signifies that that's a demand side of the problem. Using this willingness to pay function, we are able to graph a new demand curve. So if Q is equal to 0, then P would be equal to 175. So that can be indicated on the graph. And also if P is equal to 0, our output would be 350, which is also indicated on the graph. Connecting those 2 points gives us the new demand curve. So that is our new demand curve. Recall that our willingness to pay hasn't changed, so it's the same as it was before, and it's P is equal to 10 plus QS. So we have the new intersection point of a new equilibrium, which is point X, and we would need to find the equilibrium price and quantity of the new equilibrium. So how do we do that? We do that by equating the willingness to pay to the willingness to accept. And of course, we know that our willingness to pay, our new willingness to pay is 175 minus 0.5 multiplied by Q, which is equal to our willingness to accept, which hasn't changed, as 10 plus Q. So solving for Q, we would take like terms on the same side. So 175 minus 10 is equal to Q plus 0.5 Q. Which gives us 165 is equal to 1.5 Q, and if you divide by 1.5 on both sides, it gives you an output of 110 units. So that's the equilibrium output. In terms of calculating the equilibrium price, we do the same thing that we did before, substitute the equilibrium output into any of the two equations, the willingness to pay or the willingness to accept equation. So using the willingness to accept equation, we just insert the value of Q and we have a new price of $120 as our equilibrium price. So having discussed the concepts of consumer surplus and producer surplus, we can apply them to this new demand curve. So the consumer surplus would be calculated as usual because it's represented by the triangle XYZ. So we use the formula for calculating the area of a triangle. So the base would be 110, the height is 175 minus 120. We multiply those two values and then divide by 2, which gives us $3,025 as consumer surplus. As for the producer surplus, it's represented by the triangle WXY, and the calculations are in such a way that it's 110 multiplied by the height, which is 120 minus 10, and that is divided by 2, which gives us producer surplus of 6,050. You might want to take note that the way I drew the graph shows as if the producer surplus is smaller than the consumer surplus. This is just drawing, it's not drawn to scale, but in actual sense, the producer surplus is supposed to be bigger than the consumer surplus. In terms of whether this new equilibrium is efficient or fair, we know that it is efficient based on the explanation that we had before, and if it's fair, we know that the issue of fairness is hard to determine. And so we follow the same explanation that we had before.